Hello everyone, welcome to my channel, and today we'll be talking about RAG cost optimization. So imagine this, your RAG prototype costs $50 a month, cute, manageable, you shipped it. 3 months later, you have real users and your bill is $5,000 a month. You haven't changed a single line of code, you just got popular. This is the most common surprise in production AI right now. A 2025 analysis of 86,000 developers found that 40 to 60% of LLM budgets go to operational inefficiencies, not the actual value generation. Tokens being sent that didn't need to be sent, models being called that didn't need to be called, context being stuffed that wasn't helping the answer. The fix is not switching to a cheaper model and accepting worse outputs. Research shows you can cut LLM cost by 60 to 80% with the right optimization while maintaining or actually improving output quality. So one published study demonstrated a 98% of cost reduction through combined techniques. So in this video, 5 specific techniques ranked by ROI with real numbers for each will be there. No vague advice, actual saving you can implement this week. So let's move on to the next slide. Yeah. So where your money actually goes. Before optimizing, you need to understand the cost structure. Most teams optimize the wrong thing because they don't know where their tokens are actually going. So the core pricing mechanism would be like LLMs charge per token processed, roughly 4 characters or 0.75 words per token. Input token and output token are priced separately. And output token costs 3 to 5 times more than the input tokens per unit. But here's what surprised most teams, that input tokens dominate the total spend, not the outputs. A typical rack pipeline with 10,000 token context sends 10,000 input tokens and generates 200 output tokens. As those ratios, even though output is more expensive per token, input is still 85 to 90% of your bill. That means cutting input tokens is where the money is. So let's move on to the next slide. If you want, you can screenshot this slide also. So here is what fills the typical rack context window on every single call. So here retrieved chunks is around 2.5 to 5K tokens. Okay, which is the biggest target. So a standard rack pipeline retrieves 5 to 10 chunks of 500 tokens each. For example, then 2500 to 5000 input tokens per query, just for context. And a lot of that context is marginal. So the third, fourth, and fifth chunks are contributing very little to answer quality while adding significant cost. So now let's move on to the techniques how we can optimize cost ranked by ROI. So the first technique, that is prompt caching. Here we have the highest ROI. So implement this first today and we expect a saving of around 60 to 90% of your current cost. So most LLM providers now offer prompt caching. The concept is that if the same prefix, that is your system prompt, your document chunks, your tool definitions, appears across multiple requests, you pay to process it once and get a dramatically reduced rate on cache reads. According to Anthropic pricing, the cache writes cost around $3.75 per million token. Cache read cost only 0.3 per million token, a 90% reduction on repeat content. OpenAI caches automatically on compatible prefix at a 50% discount. So let's talk about a real example with numbers. A RAG customer support system sends 1,000 requests per day. Each request has a 10,000 token system prompt plus the documents plus a 50 tokens for the user query. Without caching, that's around 10,050 tokens into 1,000, that is the request, into $3 per million token. That is around $30 per day input cost. With caching, pay once to write the 10,000 token prefix, then the triple line reads at 0.30 per million. So total drops to $6.18. That's an 81.4% reduction. Same quality, same output, just not paying to reprocess the same token 1,000 times a day. So the implementation rule is structure your prompt so the stable content, that is the system prompt, reference documents, tool definitions come first. The variable part, that is the user's query, come last. So providers cache from the beginning of the context. So stable content at the top maximizes cache's hit. Okay. So let's move on to the next technique, that is the context compression. Here we expect a saving around 40 to 60% of the input cost. This is the second highest ROI that we can implement after caching is running. Okay. So your RAG retrieves 5 chunks. 3 of them are genuinely relevant, for example. 2 are marginally related noise. Okay. So you are paying for all the 5 equally. Context compression fixes this. There are two approaches. The first is retrieval reduction. Instead of retrieving the top k chunks and sending all of them, we retrieve more candidates, say top 20, and use a re-ranker to select the true relevant 3. Re-ranker models are cheap, like cross encoders inference cost fractions of the around cent per query. Okay. So the LLM call saving from sending 3 chunks instead of 10 pay for the re-ranker many times over. The second is the chunk summarization. Before injecting a retrieved chunk into the prompt run, we run it through a small cheap LLM and ask it to extract only the sentences that are relevant to the current query. So a 500 token chunk, okay, often summarizes to 80 to 100 tokens while retaining 90% of the signal for the specific question. This is the context engineering from the video 11 that I talked about in this series that is applied to the cost reduction. The same principle now with a dollar sign attached. So for the tools, we can use LLMLingua. Okay, it's an open source compression library that achieves around 5 to 20 times the prompt compression with a minimal quality loss. A study showed compression from 800 tokens to 40 tokens, a 95% reduction or a certain use cases are possible. So it's particularly effective for RAG systems with long retrieved context. So the next technique is the model routing. Here also we are expected to saving of 40 to 60% of the model costs. Okay. But in this, we require a routing layer, but pays off at scale. So you are almost certainly using the frontier model like GPT-4o, Claude Sonnet, Gemini Pro for every single query your RAG system receives, including the simple ones also, including like what are your open hours, for example, including how do I reset my password. So that is like hiring a surgeon for a bandage, the paper cut bandage. So the pricing spread should be like the budget model's cost is around 15 to 50 times less than a frontier model per token. So Claude HiQ 4.5 is $1 per million token inputs versus Sonnet is $3 per million, whereas Opus is $5 per million. And GPT-4o mini versus GPT-4o is also a similar gap. So most production RAG queries, the simple factual retrievals do not need a frontier model quality. Model routing, which is the build a lightweight classifier that categorizes incoming queries by complexity. Simple factual lookups, greetings, and single document retrieval go to the budget model. Multi-hop reasoning, okay, like synthesis across many documents and edge cases go to the frontier model. Research shows that 60 to 70% of your API calls can run on the budget models without quality loss. As a practical starting point, add one line to your RAG evaluation pipeline from video 8 for every query, log the faithfulness and the answer relevancy scores for the ragas. Identify the query types that score equally well on the budget model. Route those. Start simple. You don't need ML to classify or else what are the hours and these kind of questions. You don't need this ML to classify. as a budget model query. Okay. So next technique, that is semantic caching. Here also we are expected savings variable up to 73%. So this is also high ROI for repetitive query load. So prompt caching saves money on a context prefix. Semantic caching saves money on entire queries that are similar to ones you have already answered. Here's how it works. When a query comes in, converts it to an embedding and checks if a semantically similar query has been answered before. If the similarity exceeds a threshold, say 0.95 cosine similarity, return the cached answer without calling the LLM at all. Zero inference cost, so near zero latency. When it works, let me tell you. So customers support FAQ systems, internal knowledge bases, where many users ask variation of the same 50 questions. Okay, in this case, this works, this technique. Production implementations report semantic cache hit rates of around 40 to 68% on these workloads. At a 68% hit rate, you are making 68% fewer LLM calls. So that maps almost directly to the cost. When it doesn't, let me tell you. So highly unique queries, complex reasoning tasks, a personalized or context-specific questions, don't force semantic caching on workloads where queries are genuinely diverse. You will get cache misses with added latency and no benefit. So next technique, that is output constraints. Here also expected saving is around 30 to 70% of the output cost. It is quickest to implement, often overlooked because of the output token seems cheap. They are not. Output token cost also 3 to 5 times more per unit than the input token. And most LLM outputs are longer than they need to be. Because you didn't tell the model to be concise, like you have for this, you have to set max token explicitly in every API call. Okay, if your UI shows a 3 sentence answer, set a max token of 150, not 1000. Add length constraints in the prompt itself. Answer in 2-3 sentences maximum. Return only a JSON object with the fields. List the top 3 only. Okay, these are some methods. Apart from this, request structured output formats. So JSON prevents verbose explanation. If you only need sentiment plus confidence, for example, ask for exactly that and nothing else. So let's move on to the next slide. As you can see, so customer service response that has 500 tokens can often be 100 tokens with the explicit constraint, same information, better formatted, 80% cheaper on the output size, as you can see. So here we have done this prompt caching, then the context compression, then the model routing also, then semantic caching also if needed, and then output constraints. So this is how we reduce 80% of the cost. So let's move on to the next slide. Yeah. So as you can see here, you can take the screenshot of these 5 techniques. Okay. So just to recap, in the prompt caching, the expectation is of saving is the highest compared to other methods. Here the efforts are low. Okay, we restructure the prompt order and it's best for all rack systems. Okay, so this can be done first. Second is the context compression. So here expected is 40 to 60% of the input cost. Implementation efforts is medium. Same goes for model routing, which is also same, medium efforts are there. Okay, and it's context compression is for the large context tag. Model routing is for high volume production. Okay, and the fourth priority here is semantic caching up to 73% of the LLM calls. So it is medium efforts. Okay, we can add the vector cache layers in this. Okay, apart from this, it's best for repetitive queries workload. Output constraints. Here the expected saving is around 30 to 70% of the output. Okay, the implementation effort is low. We add to the every prompt. Best for all systems. We can do this today itself. Okay. So let's move on to the next slide, which are the hot takes. So the hot take number 1 is 40 to 60% of your AI budget is going to waste right now. This is not speculation. A 2026 analysis of 86,000 developers also found that nearly half of the LLM spend goes to the operational inefficiencies. Tokens that weren't needed, okay, models that were overkill, context that wasn't helping, Okay, these all were the inefficiencies in the operations. Before you negotiate your API contract or shop for the cheaper models, audit your token usage. The waste is almost certainly already in your pipeline. It's been available a lot about this hot take number two, that is the prompt caching is the most underused optimization in production RAGs. So it is available in Anthropic APIs since 2024 and OpenAI's since 2025. It requires restructuring of your prompt so stable content come first. Thus, the entire implementation for the most systems, it saves 60 to 90% on the repeated input cost, and a shocking number of production RAG systems are not using it. If you take one thing from this video, it is this. Check if your prompt are structured for caching. They probably aren't. Hot tip number three, that is switching to a cheaper model is the last resort, not the first. The instinct when the bill is too high is to downgrade the model. Most teams do this and accept worse quality, but the technique is in this video as caching, compression, routing, output constraints can cut your bill by 60 to 80% while keeping the same model. So you might not need to downgrade at all. So let's wrap up. So the 5-point action plan is as follows. This week, enable prompt caching. Okay. Restructure your prompt so stable content like system prompt docs come first. This frees your 60 to 90% of the savings on repeat calls. And this week, also add the output constraint to every API call. Set max token, add length instruction, request JSON where possible. Next week, add a reranker between the retrieval and generation. Retrieve the only top 20, inject top 3. You are already building with fewer token in. Next month, instrument your pipeline, log tokens per component per query. You cannot optimize what you cannot see. When you have data, build model routing, route the simple queries to the budget model, keep frontier for complex reasoning. So the combined effect of all five is research backed and it reduces 80% of cost. It is not theoretical, implemented by the real teams on real production rack systems with the billing receipts to prove it. What's your current monthly LLM API bill, a ballpark range? And which of these five are you already doing? I want to see where the community actually is. So comment below. Next up, we keep on coming with different AI concepts and new developments that come up in AI in architecture and production level so that you can build and optimize, learn parallelly and have lot of success in your career path and do quite great innovations in AI. So stay tuned and see you there.